and relative molecular mass. First, we have to learn these both concepts, and then we will be going for the mole calculation. Okay. Now, this relative atomic mass and relative molecular mass just has one equation. You just have to know the equation and to substitute on, okay? So when you take the relative atomic mass or the relative molecular mass, now what's the difference is relative atomic mass is for atoms, that means just single elements like sodium, then magnesium, aluminium. Likewise, for single elements, we define the relative atomic mass. Okay, this is basically the mass of it. Okay, mass of the elements. If it is a molecule, now molecule, it is composed of more than one element. Okay, a molecule is composed of more than one element. For example, we can take carbon dioxide. You can also take O2. This is also a molecule. It's not a element. So you should know the difference between molecules and elements. Elements is just single one component, but molecules are made up of two or more elements. So you can take NH3. Likewise, you have different atoms and molecules. Now, in this lesson, we are going to analyze their mass. Okay, mass, and then we will express their mass in the concept called mole. Okay. Now, in order to calculate these atomic mass and molecular masses, there is an equation. So you will take the mass of the element or compound. Compound is basically the molecule. And then there's a standard. Now, whenever you get the name relative, we are always seeing the mass of an element or compound relative to a standard. Okay. So already the chemistry people, they have taken the standard as 1/12 the mass of carbon. Okay. So you are relative to this, you are seeing how much is the mass of the element. Okay. For example, let's say, this is just for an example. This is sodium. Now, sodium's mass is, let's say it is 24 grams, just for example, okay? And our carbon, okay? Our carbon, let's say it is 12 grams. Now, when you consider relative to carbon, can you understand sodium is twice? Relative to carbon, sodium's mass is twice. So that's how this equation also comes. Relative, but here we are taking relative to the what? 1/12 the mass of carbon. That is the standard. You don't need to know why it came. But relative to this, we will divide by the mass of that element and take the relative atomic mass or the relative molecular mass. So you need to know the equation because they will give this data, okay, and then ask the correct substitution. Okay, so we'll see for the past paper MCQs. You have to keep this equation memorized. So this is how we are seeing the relative atomic mass or relative molecular masses. So you should remember this equation. But for us, everything is pre-calculated. Come to the next page, 125. Yeah. Can you see that table? So all the elements, the relative atomic mass are calculated. Okay. Hydrogen is 1. You can see calcium is 40. Okay. So everything is calculated based on this equation. So you don't need to how substitute and calculate. But you should know the equation. Okay. So everything is pre-calculated and these values also in the exam they'll give. You don't need to memorize. Okay. Everything will be given. So, but you should know the concept. This equation you should know. Yeah. So I want to copy this equation now. So you can put the seventh lesson topic and copy the equation of that equation. Okay. Okay. Now we'll see. Now in this equation, there is one question point, that is you are getting a MCQ pattern. Okay. So let us learn that. So they have given us some data that mass of oxygen is 1.2.66 10 to the power minus 23 grams. Now you can see how very small it is. 10 to the power minus 23 means this decimal will go behind 23 times. So it's like 0.000, very minute amount. Okay, masses. That's why they put in this scientific notation. So the mass of carbon 6, that is 1.9 grams. Now they are asking the relative atomic mass of oxygen. Okay, so first one I'll do. So they're asking the relative atomic mass of oxygen. Now you know the equation, right? The relative atomic mass is equal to, what's the equation? You should have the mass of the element on top. So mass of the element means the element they are asking for. From here it is the oxygen. Therefore it is 2.66 into 10 to the minus 23 on top. Then you remember the denominator 112, the mass of carbon. So you have to first put 112. What's the mass of carbon? 1.9 into 10 to the power minus 22. So this is the answer. Okay, so you are not expected to calculate this. Okay, so in the MCQs you will have different. Now this is the correct variation. Now you'll have different variation. They might put 12 on top. They'll put this bottom. You have to just pick the correct substitution only. Okay. So first you write this as an example. After I'll give you one word. Mhm. Yeah. Okay. Now let's see one other. They have given the mass of potassium 6.4 minus 23, and this is again 1.9 So you have to find the relative atomic mass of potassium. So just substitute, okay? Same like earlier. Okay. So you should have get 6.476 into 10 power minus 23 on the numerator. And on the bottom, you should have 112 the mass of power. Got it? Okay. So that is the question point on this. Same way they can give this for molecules also. Now molecule or atom, same equation, okay? No difference. Now instead of potassium, you can have molecule. Now molecule means it should trick your mind that it is made up of more than one element. Okay, now let's take a molecule. Okay, they have given water. So mass of water. Water is what? H2O. 2.99 into 10 to the power minus 23 grams. All in grams. So now they will ask the relative molecular mass. Now earlier I put RAM because it atom. Now it's molecule. Okay, relative molecular mass of water they are asking. So very simple, the same equation. Okay. So in the numerator you should have the mass of water. Now you will have mass of water on the numerator. Into 10 power minus 23 over 1 divided the mass divided by 9 into 10 power. Okay. Now see on numerator you have gram, in denominator also you have gram. So both these gram will cut. That means this has no unit. Relative atomic mass or molecular masses, there is no unit. Okay. So copy this down. Amen. 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 Nasa pula para ko ba? Okay. Done. So they can give this for both molecules and water, but it's the same equation. And then now write this point. Okay. So I started the first part of this lesson, so we can do. Notes? Yeah, take down this. How many pages want to do that? This one page. Wait, I'll tell you the. So I'm writing this topic, okay? Write this topic. Okay. Now we are going to see how to calculate the relative molecular masses of compounds. Okay, so this is coming for compounds only. Now in your book, in the third page of this lesson, they have given all the relative atomic mass values of the elements. Okay, for each of the element, they have given the values. Keeping that, we can find the relative molecular masses of compounds. Okay, so I'll do a few examples. So I'll take water first. Now you are getting a question to calculate the relative molecular mass of water. Okay. Then they will give in the bracket the atomic masses. Now hydrogen's atomic mass is 1. Oxygen it is 16. Okay, they'll give the values. Okay, you don't need to memorize. So they will give the each element's atomic mass they'll give. And then they'll tell you to calculate the molecular mass. Now, this is important because for the mole calculation, this is coming. Okay, so it's very important you get the basics of this. So you have to take now each element. Okay, now you have how many hydrogens in this? Two. Water molecule has two hydrogen and one oxygen atom. So now first you have to take the relative atomic mass of hydrogen, which is 1, and then multiply it by 2 because you have two hydrogen atoms. And then you have to take the relative atomic mass of oxygen. Now here you have only one oxygen, so just 16. So what you do is you take the sum of relative atomic masses. Okay, in the molecule you take the sum of the relative atomic masses of the each element. So you add up. Okay, then 2 plus 16, it is 18. Okay, therefore relative molecular mass of water is how much? 18. Now we learned the equation, right? Relative molecular masses have equations. Mass of the compound over 1/12 the mass of carbon. Okay, that's the relative molecular mass equation. So that's the first thing we were learning. When you solve that equation, you're going to get 18. Okay, but this is way easier, right? Because that equation is a bit complicated. Okay, so to find for molecules, it's very simple. You have to take the atomic mass and add them up. Okay, this is also one MCQ point they used to ask. Now let's see another element, carbon dioxide. The carbon is 12. Oxygen it is 16. Okay. Now again, you have to take the sum of the atomic masses. You have one carbon, which is 12. You have two oxygens, therefore 16 times 2. So you get 4. Okay. This is the molecular mass of what? Carbon dioxide. This is the molecular mass of water. Likewise, now if they give any compound, you can find. You just have to add up. Okay. Is that clear? Any doubts? Okay, now take up this example. After that, I'll give you a list of compounds to calculate. Okay. Okay, done. So now I'll give you some compounds you have to calculate. So, now this one's relative atomic masses. Okay, refer in your textbook. Here, page number 125. Okay, we have these relative atomic masses. So you can refer them. So I won't write them. So first see what are the different elements and find their radioatomic masses. And then you have to see the quantity, how much you have. Either it's 1, 2, and then add up. Okay, that's it. You will get big compounds also. Now this is glucose. This is A6H12O6. This is sucrose. This is alcohol. Yeah, fine for this.